Now suppose we have any component with varying cross section, looking something like this thing. So and it is being subjected to the load P. Now we have to find out what is the delta L for this tapered rod. So we can say that um, for this thing the diameter is D2, and for this thing the diameter is D1. Now we have to take any cross section here whose this thing whose diameter is, we can say it is D here, and we can take the reference line from this direction, that is X direction. Okay, so at this point basically it is x equal to 0 and y1 equal to d1, and at this reference point we can say x is equal to L and y2 equal to d2. So and we can say that here d is varying, so this is the function of x. Okay, now for varying section we know that delta L is calculated by this equation, 0 to L p dot dx upon AE. Here p and e are constant, so we will take it out. P by E, 0 to L dx upon A, and here A is pi by 4 d square, A equal to pi by 4 d square. So substituting in this equation we are going to get delta L is equal to P by E integration of 0 to L dx upon pi by 4 d square. So pi by 4 is a constant term, so we will take it out. So it will be looking something like this: 4p upon pi E integration of 0 to L dx upon d square. Now we have to find using 2-point straight line formula, we can find where d is equal to y at any x. So we can write by using 2-point straight line formula, that is y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. So we can further simplify it. So we can write d minus d1 divided by x minus 0 is equal to d2 minus d1 divided by L minus 0. Now let's further simplify it. Let me clear this thing first. Okay. Okay, so let's solve here further. So we can write here d minus d1 by x is equal to d2 minus d1 by L. So we can say d2 minus d1 by L. We can assume that it is alpha assumption. We can say d2 minus d1 is equal to alpha assumption. So we can write d minus d1 is equal to, we will bring x to this side, so it will become alpha x. So we can write d is equal to d1 plus alpha x here. So but just we are going to substitute the value in this equation, that is delta L equal to 4p by pi e integration of 0 to L dx by d square, that is d1 plus alpha x square. Now after further integrating and solving, we are going to get the value of delta ls. Let me clear this thing up. So here delta L value for this cross section will be 4PL divided by pi E d1 d2. So this is the value of change in length for this cross section. So we have time to discuss another case. We can take the case of let me clear this thing up first. Okay, so this is the another case for this varying cross section, this thing. So this is basically a cone shape. Okay, so in this condition we will be taking a strip. Suppose it has a length L, capital L, and we are going to take a strip of dx length. This is the strip of dx length, and from this point to this point the distance is x, and the area of this strip we can write at this is ax totally. This is the volume of the strip totally. Area of the strip, just take ax. So we can write ax is equal to pi by 4 dx square. Now we have to find, so let's find out the weight of the block below element dx, below this element dx. So here the axial load is the due to self weight condition, that is wx. So wx is equal to mg. So m is equal to rho vg. So here so here the volume will be a dot x dot g. Okay, so after further simplifying, we are going to get rho multiplied by what is the area. We can say 1/3 of pi dx by 2 square dot x multiplied by g. So for the simplification, we are going to get rho g upon ax dot x upon 3. So we know that sigma x is equal to px upon ax. So basically we are going to get rho gx by 3. So this is the value of the stress induced in this varying cross section. Now let's calculate what is the delta L. So delta L is equal to 0 to L px dot dx upon ax dot e. So substituting the value of px in this equation, we are going to get del L is equal to 0 to L rho g1 by 3 ax dot x dot dx upon ax dot e. So here ax will cancel. So what we have left with is um, 0 to L rho g x by 3 dot dx upon e. So after further simplification, let me clear this thing up. So after solving, so we are going to get delta L is equal to rho g upon 3e x square by 2 from 0 to L. Let's further simplify it. So we are going to get, out of further simplification, rho g L square upon 6e, which is equal to WL upon 2EA. So this is the value of delta L for this cross section. So I think it's enough for this lecture. From like the next lecture, we'll be studying some numericals, additional numericals. So for now, thank you.